Find the X and Y intercepts and the vertical, horizontal, or slant asymptotes. All right, so for any function that is rational, for us to be able to find all of these different aspects, it's going to be advantageous to have the function written both in factored form and expanded form. So right now, this is called expanded form, but I can rewrite this in factored form just by factoring the numerator in this case. The denominator, since it's linear, I can leave that alone. So in the numerator, I need two things that multiply to give me 2x squared. So that's 2x and x. Two things that multiply to 20. I could use 5 and 4 as possibilities, although there's more options. We'll just see if this works. 5x and 8x. I can get those to 3x if the 8 is positive and the 5 is negative. And that would make negative 20, so that works out just fine. All right, now, X-intercepts. So the location of X-intercepts, these happen where the numerator is equal to 0. So we just take any of the zeros in the numerator, the factors in the numerator, and set them to 0 and solve. So for instance, if I have 2x minus 5 and I set that to 0, then that gives me 2x equals positive 5 because I need to add 5 to both sides, or x equals 5 halves. So what that means is I have an x-intercept that has an x coordinate of 5 halves and a y coordinate of 0. And then likewise, if I have x plus 4 and then I set that to 0, that gives me x equals negative 4. So I have another x-intercept at negative 4 and 0. Now, y-intercepts, these come from the ratio of constants. So in this case, the constant terms are negative 20 and 2. So my y-intercept, it's going to have an x value of 0. That's going to put it on the y-axis. And then if I take the ratio of negative 20 over 2, that's going to be negative 10. The horizontal asymptotes. Horizontal asymptotes, there's a set of rules that we work with, but generally what we do is we take the leading term of our polynomials and we compare their degrees. So the degree of the numerator is larger than the degree of the denominator. And the rules that we have tell us that there is no horizontal asymptote. So in this case, the horizontal asymptote does not exist. What happens is we actually have a slant asymptote. So to get the slant asymptote, because the degree happens to just be 1 larger in the numerator, what we have to do is divide the polynomial. So divide the rational. Now, if we have a denominator like this with x plus 2 where it's a linear factor, the leading term coefficient is just 1, we can actually use synthetic division. So that's great. That'll make things easier. So synthetic division, what I do is I take the 0 in the denominator, so I change the factor into a 0, divide it into the coefficients, so 2, 3, and negative 20. The coefficients of the numerator, that is. So bring the 2 down, that's 2, 2 times negative 2 is negative 4, those add up to negative 1, that's 2, and this is negative 18. Now, the only thing that really matters is these two coefficients here make up a linear function, where this is a constant, and this is times x. So that slant asymptote is made up of that linear function with these coefficients. So the slant asymptote is y equals 2x minus 1. Vertical asymptotes. Vertical asymptotes occur where the denominator is equal to 0. So in this case, it's similar to the x-intercepts, but now we're just looking for the denominator. So we take any zeros or any factors we have there, set them to 0 and solve. So if I take x plus 2 and set it to 0, I get x equals -2. And I don't need to change that into a coordinate pair because a vertical asymptote is a vertical line.